Question 7 from tutorial 3. We are dealing in this question with Newton's second law. This gives us this differential equation. M, our mass, times acceleration, dv dt, equals to mass times gravitational constant g minus c times v. mgc, as we mentioned, are constants. We need to find a formula for the velocity. We need to show this formula. Then we need to find the limiting velocity, which is taken as a function in terms of time. We want to see what happens when we take the limit as t goes to infinity. Finally, we want to obtain a formula for distance in terms of time. So distance x of t after t seconds. For the first part, we will make use of integrating factors once again. This is our differential equation, so we will rewrite it a little bit. We'll take the part involving v and shift it to the other side. So we will obtain this formula. Notice as well, I divided throughout by m. So dividing by m gets rid of m from dv dt, gets rid of m from g, and we must divide by m for v. This is of the form dv dt plus a function in terms of t times v equals to h of t. We can work with this. So f2 is simply c over m. We integrate that, we get c over m times t. Then we multiply throughout by e to this power c over m times t. This should be what we get when we multiply everywhere by means of our integrating factor. After we have done this, the left hand side becomes a single derivative d dt of exponential function times v equals to g times exponential function. G, as we said, is a constant. The next step, of course, is to integrate. So the left hand side is e c over mt times v, and we have to integrate this exponential function. What this gives us is g times m over c times the exponential function plus our arbitrary constant c. Obtaining this is precisely what we will get over here. And so, because, once again, this is an exponential function, it's always positive, we can divide by it. So v can be expressed this way. It equals gm over c plus arbitrary constant times exponential function. At this stage, we use the information from the question to solve for the value of c. At time t equals to 0, the velocity is given by 0. So we'll substitute these pieces of information into our differential equation. When t equals to 0, e of 0 becomes 1, v is 0. Therefore, from this, we see that c equals to minus mg over c. Putting that into our differential equation, we can simplify this, and this is the formula we get. V equals to mg over c times 1 minus exponential function to the power minus c over m times t. Precisely what we are trying to solve for. Now with this formula, we can find the limiting velocity. We take the limit as t goes to infinity within this formula. But the only thing which depends on t is this exponential function. And as we take the limit as t goes to infinity, it tends to 0. The limit of this term is 0. The rest of the expression doesn't depend on t, and therefore, using standard limit laws, we see immediately that this limit equals to mg over c. This is our limiting velocity. What about distance at time t? Well, we note that distance is related to the velocity, in that velocity is the rate of change of distance x with respect to time, i.e. dx dt. So to obtain the formula for x of t, we need to integrate v. But note here, x of t should be a positive number. It should give us distance. But if I don't have my limits of integration, this thing would have an arbitrary constant. That is not what I want. But in fact, what happens to be the case is that because I want the distance at time t, I need to integrate over the interval from time t equals to 0 to the time that I want, which is precisely t. In this form, this quantity will give me a positive number, and this is going to be the distance that I want. So in other words, we're taking our formula for velocity and we are integrating it. If we do that correctly, we should get this particular expression, mg over c times t plus m over c times our exponential function minus m over c, which is a real number, and that will be the distance our object has traveled from time t equals to 0 to the specified time t that we want. So this solves question 7.